Reading instruments is one of the most important things that you do in the laboratory, and above all, you must learn to read these instruments properly. The idea in calculations with measured values and recording measurements properly is all connected together. And the basic idea is this. I will have an instrument. I'm going to draw a very generalized instrument here. It can mean anything at all that has a scale on it. And it will be marked typically in units of, for example, 10, 20, 30, 40. Often these units would be given. They might be centimeters, they could be grams, it doesn't matter. 10, 20, 30, 40. And what we'll find is a rather consistent pattern in scientific instrumentation is that these large units will be broken into smaller sections of 10. And in this case, I'm going to break this into 10 units. Notice what I've done here is the middle break is a little bit larger than the others to give you an idea of where you stand. And so often you won't see numbers under these markings, but this would have to represent 1 unit, 2 units, 3 units, 4 units, finally up here to 5 units, 6 units, 7 units, 8 units, 9 units, and finally 10 units. And you would get the same set of markings further down, but it gets rather tedious trying to draw these, and I'm not going to bother. The essence of making a measurement is that when and let's imagine, for example, this were a centimeter measuring device, and I had some object that fell, let's just say, about there. I can clearly see that this instrument is telling me that I have 14 units. If these were centimeters, then I know the units I'm measuring are centimeters. However, also notice I can guess between the 4 mark and the 5 mark here. I know that's 14 because of the 10 over here. But in terms of guessing, I might look at that and say, oh, that looks about 4/10 of the way over, so I could say 14.4. Always, this last digit I record in my lab manual is going to be what we call an estimated or guessed digit. And it's always going to be 1/10 smaller than the last marked unit. Last marked unit. In this device, I have marked in tens, which means, I have marked in ones because I have 10, 20, but I have the 1 marks in here, and so I must record to the nearest tenth. On the other hand, I'm going to blow this instrument up. If I had the same kind of instrument here, but say it would have read 10 here, and it read 20 there, and again, when I looked at this, I saw my halfway marks here, and 1, 2, 3, 4, 1, 2, 3, 4. Now let's just imagine I had 10 more little marks in there, in between here. And again, it doesn't matter that it's hard to read them. You'll see this is very much a problem in the lab with a meter stick. But let's just say, for the sake of argument here, that in between, say, each one of these little marks here, I had 10 more little marks, which you have a hard time seeing. The point is, and I'm going to blow this up now, so imagine this was the 10 mark, and this was the 11 mark here. And I have, again, broken this into 10 equal places. And again, let's assume this is centimeters, because in fact this is the way your centimeter stick will look in the laboratory. And I can see here that I have 10 and 11 is here, and I have a little thing that falls here somewhere, and I'm just going to pretend, okay, I'm looking at it from this perspective. So I know it's more than 10, but I know it's not 11 centimeters. It's somewhere in between 10 and 11. And I look at that, and that looks definitely 10.2 here. In other words, it's not 11, but it's 10.2, and that's definite because I can see that's where the thing is. But then I have to guess. It's just a skosh past that 0.2, and maybe I say it's 1. So I have to write that as 10.21 centimeters. Even if I were to have some other little thing that I measured that fell smack dab on the 11 mark, for example, I would have to read that as 11.00 centimeters. This information here is telling me that I am guessing to the 100th because the object is marked in tenths. So the last explicit mark is here. and I always have to show something 1/10 smaller in my recorded reading, despite the fact it could be a 0. And in fact, in this example, since it fell right on the 11 mark here, then we're saying that, the 10th mark was 0 too. But I still have to show it in the hundredths, and that's a very important kind of an idea that we'll see over and over and over again.